Stats class, getting ready to take our AP exam in a few weeks. We're going to go over numbers, hopefully 1 through 10 in this video. All right, so take a moment and read number 1 if you haven't already. Now, as we get into number 1, there are, in the answer choices, some vocab you need to remember from the first semester. So who remembers what bimodal means?
So basically,
two humps, right? 2 modes, 2 humps. So we're looking, does this have 2 humps? It definitely does, right? There's 1 hump and there's another hump. All right, so it's not going to be A, D, or E. Remember skewness? How do we describe skewness?
so like if it like leans,
Leans? Which direction? Depend, right? So if it says skew to the right, where's the tail going? To the right. So it'll be like this. That's skew to the right. And then skew to the left. Skew to the left. All right? So the question is there a gap? Is there a gap? Where is that gap?
right there because
Thank you for that. Right there. There you go. Right here, it looks like there's a gap. All right? So make sure once you see that gap, right, you know that it's bimodal with a gap. Number 1 is C. Hopefully you're 1 for 1. Ooh, an outsider. No, that's a book called The Outsiders. If you're going to say outlier, possible or probable, both are fine. Because do we know if that's an outlier? If those are outliers, we do not. So they could be possible outliers. Let's do number 2.
you like the outsiders?
Let's do number 2. Now, number 2. I know it's been a couple weeks since you took this, or some of you haven't taken it. But the key phrase here, key phrase in number 2, is given that the person selected is age 55 or older. All right, so when you look at this table, which if you didn't know, this is called a two-way table, right? Or another word for that? Contingency table. Hey, Marco, hey, you didn't bring your stuff, but hey, you know some things. Nice. All right. So I'm only focused on this column. All right, it says age 55 or older. So how many total people are age 55 or older? 44. So I know my fraction is going to be 44. All right, it says, what's the likelihood that we select someone who responded no? 36 over 44. Open that calculator. Open the calculator. I will open my calculator as well. Excellent. So you can find the answer already, Adrian B. And make sure that we're all understanding that you're not using decimals for this. You're using a calculator. Because they're 20 years old. Okay. Don't worry, we're going to use, next year, we're going to use Edder's app that he made. So thank you, Edder. All right, are you ready? All right, so do you guys see my calculator? All right, so we're doing 36 divided by 44. You should be doing the same thing in your calculator. 36 divided by 44. Enter. So the answer is 0.818, which is letter E. Any questions on number 2? Hopefully you're 2 for 2. Me too. Let's go number 3. Oh my gosh. All right, number 3. Whoa. So first semester. Okay. So we have this right here with all these little dots that are scattered about. So what's it called? It's a scatter plot. Very good. Definitely not a cloud, right? They're saying that there is a linear relationship. Do you see this line right here? This is the linear regression model. Okay? The linear regression model. Another word for it they have up there is the least squares regression line. So right here, the least squares regression line. Just means the same thing. The linear model. Okay? And they're wanting us to focus on this point right here. Okay? And it's asking us, based on this over here, and what is this plot called? Residuals plot. This is where we're hoping to see no pattern, right? We want to figure out on this graph, graph 2, what's going to represent that circle point from graph 1. So the key thing I started out in this problem is you need to know what is a residual. Well done. I'm going to change one of your words to predicted, but it's the same thing because when I use the vocab on that unit from chapter 8, 9, and 10, Adrian V, I use the word predicted a lot. Okay? All right, so let's see if we can eyeball this. I'll do a little line here. All right, so I'll do a line over here. What do you think is the actual value for the fleece weight? I was going to say a number. It's like just under 5, so I used 4.9. You can choose whatever you want. I wouldn't choose 5. It doesn't look like it's at 5. You can use 5. It's close enough, whatever. Something around 5, okay? Now, do you remember how to find the predicted value? Look at the line, yes. What's that line called?
The line regression.
That's also fine, yes. Marco?
I do.
The least squares regression line, excellent. Yes, yes, Jasmine. You are in line. All right, so now if you look up here, if I draw a line up here, and then I go over, I said 9.5 personally, but that's fine if you use 9. My line's not the greatest, so it's probably actually closer to 10. So what is my residual? If I subtract this, what do I get? Is that it? Negative 4.6? Did you get it right on the dot? Wow, well done. I'm impressed. Okay, so now I'm going to go to graph number 2. All right. The key thing I noticed about my residual is that it's negative. Do you see that? That means the model is predicting a value higher than what's actually happening in our experience here. Okay? So when I look at my residuals plot, right, my dot needs to be negative. It needs to be below 0. So which one am I crossing out right away? Because it's not negative. E. Right? E is up here. That's in a positive. So no, that's not going to work. All right? How are we doing so far?
Pretty good.
The next thing I read is I read the x-axis here. What's the x-axis? Predicted fleece weight, which is which number that I made up? 9.5. So now I'm going to go to 9.5, which is, I guess, I was wrong. It's more like 9.75. All right, so it could be C or D. So which ones am I crossing out next? A and B, because they're not at the correct predicted value. All right, so now the question is, when I look at these, I'm hoping that these Y values here are around negative 4.6. And this one for D looks to be about negative 3. But letter C is just past negative 4, so I'm going with letter C. Well done. That is a lot of work. Welcome to AP Stats. Okay.
But this is the concept behind it.
Yes.
Like, let's say you can't figure it out.
I'm hoping people watch this video and they learn something from it. Not just, hey, it's easy. Just look at it.
Right.
The next one, number 4. All right, so we have 4 histograms. And it says, which of the following is not represented by one of these 4 distributions? So we've already gone over bimodal and skewness. Hopefully, please, Lord willing, we know what symmetric and unimodal means. All right, so the question I have is for you right now is, what is uniform?
All the same.
They're all the same height, right? They're all the same height. So when you look at this, right, this looks bimodal. This answer choice here looks to be skewed to the right. This one looks unimodal and symmetric. This one looks skewed to the left. So which one do you not see?
Uniform.
You don't see all of them are the same height. So uniform. That's Marco making weird noises. Let's go to number 5. Number 5. All right. Now this is going to seem somewhat similar to, I believe it was number 2, but it's a little bit different because this question says, of the people. Of the people. So how many people did we have? 1,092. So 1,092. and 92. That's all the people. And we want to find out the likelihood that they're going to be no to color consideration, and they identified safety as their additional feature that was important. So I'm going to know, and safety, which is 192. All right, so I went to no and safety. And now where am I going? I'm going to the calculator.
Oh, is it calculator?
To type this in, you should be doing the same thing on your desk. 192 divided by 1,092. Ooh, where'd you go? There you are. So what do we say? 192 divided by 1,092, which is 0.176. 0.176 or 0.18. Number 5 is the closest. Are you guys okay? Okay. Questions on number 5? All right. All right, let's go to 6. And it begins. I'm going to use the formula sheet. Let me open it up. I'm just opening up the formula sheet because I'm going to need it here in a moment. There it is. Okay. All right. So number 6. It's telling us that the distribution of the lifespan of the Galapagos Islands giant tortoise, interesting, never thought about that, is approximately normal with a mean of 100 years and a standard deviation of 15 years. So what I did, you don't have to do this, is I wrote a capital N. Why did I write a capital N? Because it's normal, all right? And then we put these are called parameters, our mu, which stands for the mean, nope, not that noise, and our sigma, which stands for the standard deviation, right? So for my model here, they said 100 years for the average and 15 years for the standard deviation. Okay? Then it says, based on this estimate, so this model, which of the following is closest to the age of one of these turtles at the 90th percentile of the distribution? So this is actually asking you, do you know what a percentile means? All right, what did I just draw?
A normal.
Nice. All right, so here's what the 90th percentile means. It means that you're up here, okay, and how much, or should I say, what proportion or percentage of the turtles are below that one? 90%. Okay, so I'm going to find a z-score that's associated with that. So bless you, I'm about to show you how to do this in the calculator. Normally, we would go to one of our links. But because we live in this world where the College Board owns us, we have to use these calculators.
Wait, do we have to bring our own calculator?
No, you'll have one of these.
They'll provide it?
They will provide it? How about I will provide it? They. All right, ready? Okay, make sure you're paying attention. This is not just like division. All right, we've never done this before.
Never?
I don't think I've done it with you guys. We did something with regression. Remember that video? It was terrible. All right, ready? So hit second. So do you see the blue button? Second. Yours might not be blue. I think it's blue. Excellent. Second. And then you see VARS. See VARS? If I hit second VARS, that's actually distribution. So second VARS, which is actually distribution. All right, everybody here, you see this screen? So hit second VARS. All right, and now the key thing here, guys, is that we want the technology to tell us a z-score. All right, so that's actually backwards from the first thing we ever did in our class with z-scores. All right, before we actually took our z-scores and found the area under the curve. Now we're doing the other direction. Okay, so going backwards, I'm going to use number 3. You guys see number 3? Where it says inverse, so going backwards, of the normal model. So inverse norm means to go backwards. So click number 3. I hit number 3. What happens when you hit number 3?
Same thing.
Excellent. So click number 3. Now, we're using this idea that this tortoise is the 90th percentile. So how much of the area is to the left of this turtle? Sorry, tortoise. 90. So I'm going to type 0.9. 0.9. And then I'm going to hit enter until it gives me my answer.
Wait, we don't switch the thing?
Nope, don't switch anything. Hit 0.9 till you get here. Are you guys here now? Hit enter a bunch after 0.9. Okay, and then hit enter again, because that'll give you the z-score.
Oh, it told me to quit.
So this is the z-score, 1.2816. 1.2816.
Oh, enter again.
What number are we on? 7?
Yes. 6.
Hit enter again.
Hit enter again. Hit enter a bunch.
Dude, it tells me error.
Watch the video. Okay, so now, right? So now, if this is our z-score, all right, this is our z-score, I'm going to use one of our formulas, all right? And it is on the second page, if you've got your formula sheet out. I lied. It's on the third. There it is, the third page. All right, you guys see this third page? All right, if you're following along at home, you've got your formula sheet out. Okay, so it's this very first line where it says standardized test statistic, right? In our world, when we're talking about the normal model, what letter am I using? For the normal model, what letter am I using?
Oh, P.
No.
T.
No. Z. Someone write down Z equals. Then it says statistic, all right, which I'm going to write down Y minus our parameter, which is the mean, divided by the standard deviation, which is sigma. All right, you've used this formula before in this class, even if you don't agree. All right, plug in what we know. We know our turtle is 1.2816 standard deviations above the mean. We don't know how long it lives, minus the average of 100 over the standard deviation of 15. What have we just created? An algebra problem to solve. You're right, Adrian B. It is an equation. You should be able to solve this with basic algebra. Do I need to show the steps?
No.
Or can I just do it in the calculator?
Wait.
Calculator?
Yeah.
I'm going to show the steps in the calculator. All right, ready? I'm going to do it in the calculator. All right, ready? All right. Here's one of the cool tricks of this calculator. Mabel, did you get a new one?
How do you leave from this?
You ready? Watch this. All right. Hit clear. Hit second quit. Second mode. Which is quit. No. Second mode. There you go. Okay. So now, if you hit, this is really cool. If you hit second, and then you guys see the negative symbol where it says answer in blue. So if you click that, all right, now it's going to take my last answer, which was 1.28155,156, that whole thing, and I've got that, okay? If I do algebra, I'm going to multiply the 15 to the other side. You guys see that? So I'm going to put times 15. All right, and then I'm going to add, right? I'm going to add 100 to finish the problem.
Wait, you could just click the multiplication and it does it.
Yeah, you're right. It does it. I just want to make sure you guys see that, how to get the answer.
Okay.
All right, so how long do we expect this giant Galapagos Island tortoise to live?
119.
119 years is what I'm guessing, based on this model. Okay, when you look at your answer choices, which one are you going to choose? 120 years. Hopefully you're going to watch this video in the future, Jasmine.
Oh, yeah.
Excellent. Let's go to number 7. All right, now number 7 doesn't require a calculator. It does require you to understand, bless you,
Thank you.
what a box and whisker plot or a box plot is. Should we do a quick review of that?
No, I remember.
Let's do it.
The middle is mean.
Already 0 for 1.
That line is the median.
There are no averages here. This is the
I mean,
median.
median. There you go.
They're not the same thing.
Median. I meant
This is not going to go well in a few weeks. Okay.
Quartile 3, quartile 1.
Okay, you are right there. That's fine. Quartile 3.
Lowest and highest.
if I don't have any outliers, right? So this is min, and this is max, right? If you remember from when we did this in the first semester, this is called the 5-number summary, because there are 5 numbers you need to create a box and whisker plot. Okay, so now,
That was called box and whisker?
or box plot or box and whisker plot. Do you see the little things on the edge here, right? Those are called the whiskers. Okay, so if we look at this one, if you read choices A and B, right, I'm hoping no one picked A and B because it's talking about the number of single-day rentals. Do you have any idea how many for our data values there are when you look at a box plot? No, you have no idea. There could be 5, there could be 500. I have no idea. So it can't be A or B. You'll never know how many there are in a box plot. So that's one of the, box plots are great for comparison. That's one of the things that makes it a little bit limited, so we don't know how many data values there are. Okay, so that's gone. Then between C, D, and E, they're all pretty similar. All right, we're always looking at location B compared to location A. All right, and the first thing I noticed about location B is you see how it's much more spread out, right? It's much more spread out, so that has a larger or higher variability. All right, and then what I notice is that the median for location B is past the median for location A. So the median for location B is bigger than the median for location A. So if you look at answer C, that checks both those boxes, that location B has more variability and its median is greater. Questions on 7? Okay, she should be back soon. What's her name? Adarani! She's not in the hallway. She's not there. She's coming though.
You're allowed to do that as a teacher?
I do whatever I want, man. Come on.
That makes sense. The teacher, the boss, the teacher.
Question.
What?
Number 8.
And
Number 8. We've only done 7, right? All right, let's do 8. Another question that's a lot of reading, no calculator required. The key phrase that I saw when I read this question was it said that they made a list. So they created a list, all right, where they did every item in stock. Every item, every single thing. Every single thing. Do you know what it means when you count every single thing or person? Is a census. A census is when you count every single thing. Let's go quickly over an experiment. An experiment, the key thing you're looking for is random assignment to treatments. I should write this down. Random assignment to treatment. So experiments. Right? If you think it's an experiment, you should see random assignment to treatments, whether that's people or experimental units, right? We've done one, we talked about the chubby dogs, the 60 chubby dogs being assigned to different treatments that included an exercise and a diet plan. If you remember that example. Okay, all right. And then for a sample survey, right? A sample survey, that's talking about a sample from a population. A sample from a population. So if they had talked about only looking at part of the entire inventory, like they went every 7th item they pulled out and looked at it, that would be an example of a systematic sample, right? That every other one. Okay? You got all those? Simple random sample, stratified sample, cluster sample, systematic sample. Oh, those words are coming back to us very soon. What did you say? It is. I mean, yes. I mean, you're trying to get college credit, so why would it not be a lot? All right, let's do number 9. Number 9 is going to be a lot of work, so make sure you're writing small. All right, number 9 and 10 will be a lot of work, both of them. Then we'll be done. All right, number 9. Okay, number 9 is a lot going on, but I'm hoping that you see that they're talking about a mean weight that's the same for both of these farms, one in Iowa and one in Ohio. All right, and then it's talking about the standard deviation. All right, so when I see you talking about the mean and the standard deviation, what am I thinking about? Thinking about the normal model. Okay, so I'm going to be using this formula again. All right, to help me solve this problem. Okay, so the first thing I noticed was they told me, and I'll just start with Iowa. All right, so this is Iowa. All right, so we have z-score equals, all right, our one that they're telling us, our randomly selected ear of corn in Iowa weighed 1.39 pounds. All right, everybody good? Why I put that there? That's the one that we picked. All right, what are we saying is the average weight that we expect for these ears of corns for both of these farms? What is it? 1.26 is correct. Okay. Now, over, all right, it doesn't tell us the standard deviation for Iowa. It says something here later about the difference between the, right here, this difference in Ohio and the Iowa farms, 0.01 pounds greater, right? But it doesn't say what it is for Iowa, but it does tell us that this ear of corn has a z-score of 1.645, right? See how it says a standardized score? So can I solve for my standard deviation? Yes. If you create an equation with one unknown, you can solve for it. All right, so let's do that now. I'm not going to show my work with the algebra. I'm just going to do it in the calculator. All right, let's see if your brain is okay with it. So first thing I'm going to do is I'm going to subtract 1.39 minus 1.26. Bless you.
Is that always true?
It's always true.
Yes, if you have any equation that you don't know one of the things, you can solve it.
What about?
All right, and then if you notice with like algebra, if you move it in your brain, do you see how I'm going to move sigma over with multiplication? I'm going to move the 1.645 to the right side with division. So in here, I'm going to divide by 1.645. All right, so when I hit enter, what am I going to get? No, just like what, not the number. What am I going to get?
Oh, the
standard deviation of the weight of ears of corn in which state for this farm? Iowa farm. Okay. Yeah, this is just for Iowa. 0.079. So let's write down 0.079. All right, I'm going to pause here. How's everyone doing? I know that's a lot. We're like halfway. That's fine, go ahead. So now, what I am going to use is this piece of information that it says that the standard deviation for the weights of ears of corn from the farm in Ohio is 0.01 pounds greater than that from the farm in Iowa. So if this, and let me do this, if you guys, are you okay with it? If I put a little subscript I for Iowa, you guys go with that? So then what is going to be the Ohio one?
Oh, not greater. Oh.
How much greater? 0.01, right? So if you add that together, you get 0.089. All right? Everybody still with me?
Yeah.
All right, so now if I go to Ohio, right, not actually going, it says how many standard deviations from the mean is the weight of this ear of corn if we do that same 1.39. So watch what happens. It's the same setup, 1.39 minus 1.26. But now what is our standard deviation in Ohio?
0.089.
Excellent. And if you forgot from your days in the first semester, another way to describe the z-score is the number of standard deviations from the mean. If it's a positive z-score, it's above the mean. If it's a negative, it's below the mean. So now I'm going to type this into my calculator to get my z-score. I know, this is a lot of work. All right, so I'm going to do it quickly. So I'm going to do in parentheses 1.39 minus 1.26 parentheses divided by, and I think it was 0.089. All right, and what do you notice about that z-score? What do you notice about that z-score? It's positive. It's positive. So that's telling us that our ear of corn in Ohio is going to be relative to the mean. It's going to be above it, right? So you can look at your answer choices and cross out any that don't say above it. You guys crossing any of those out? Yes, am I crossing it? Right, above it. So we crossed out A and D because they say below. And what was our answer? 1.46, I believe, was the answer. 1.46. And so it's above the mean. So it's B, 1.46. All right. Let's do one more. And then we'll be done. All right, let's go to number 10. That was number 9. Okay. Now this one is going to be a lot of work as well. Okay? It's going to be a lot of work as well. So make sure you're writing small. Try to do this. I know I'm sitting on the ground now. I'm running out of juice, so I need some power. Okay. So we've got the distribution for the number of hours worked by volunteers last year at a large hospital is approximately normal. So the moment I read that, right, just like I did before, what am I writing down?
N.
I'm writing down N, and I'm going to write down 80 with a standard deviation of 7. Yes, you got that? Okay. It says volunteers. Shh. All right, one more, right? Come on, we can make it. In the top 20% of hours worked will receive a certificate of merit. Okay? So we're trying to find out if they're going to be in the top 20% to get a certificate of merit. Okay. If a volunteer from last year is selected at random, which of the following is closest to the likelihood that the volunteer selected will receive a certificate of merit given that the number of hours they worked is less than 90? There's a lot going on there. I'm going to leave that to the end. Okay, so the first thing that I did was I went and found the top 20%. All right? Do you know that that's another way of saying what? So the top 20%, top 20%. Nice, Adrian B. What up, man? So if this is 0.2, then this is 0.8. So if you're in the top 20%, you're the 80th percentile. Okay? So we can go to our calculator and find that z-score. All right? So I'm going to go find that z-score. Now, we've done this one time. And do you remember how we got there? It's okay if you didn't. All right, so I did second, and then I did vars, which is distribution. So second, vars. And then do you remember which one we picked to go backwards? Nice. Number 3, inverse norm. And I'm typing in not 90th percentile anymore. We're saying this is the 80th, so 0.8. And then hit enter a bunch until you get to your z-score. All right, so I'm going to write down 0.842. 0.842. Okay, everybody good so far with that? Okay. Now it says that we're looking at those people that worked less than 90. So less than 90. All right, so here's what I did next. This is for less than 90. I went and found a z-score for this. So we're using that same formula. Okay, so we're saying 90 minus, what's the average number of hours worked by these volunteers? 80. And the standard deviation is 7. All right, so we can type this into the calculator. So 10/7. It is the last one we're doing. It's a very long one. It takes a while. So we have 90 minus 80, which is 10 divided by 7. So our z-score is 1.429. 1.429. Okay. And then I went and drew another curve. I know, which 1.429 is probably like over here. And I'm shading to the left. You know why I'm shading to the left?
Yeah. Less than 90.
Because it says less than 90. That's right. Okay. So I'm going to go to my calculator. Now watch this. This is actually the first way that I taught you guys in the first semester. If you have the z-score and you're trying to find the area under the curve, all right, you're going to use not inverse norm because we're going I don't want to say the correct way, but the first way that I taught you, where you have the z-score and you want the technology to tell you what's the area under the curve. All right, so watch which one I pick again. So I'm going to go to second vars, which is distribution. So I'm not picking number 3. All right, this time I'm picking either 1 or 2, and the one I pretty much want you to pick every time, there's like one random time you wouldn't, is normal CDF. That C in CDF means cumulative. So that means you're shading, okay? So if I hit 2 for normal CDF, which way did we shade? To the left. So what's my lower number? Negative infinity, essentially, right? If I'm going to the left forever. Notice what did they put there on my lower? -1 e to the 99th power, that's times 10 to the 99th power. So that's basically negative infinity. Yes? If you are having trouble with that, just type in negative and then a bunch of 9s. Right? That's negative infinity, right? I just need something that's very, very negative. And then what's my upper one? If you need to go back to the sketch. No, 1.429. 1.429. Okay, I'm going to hit enter a bunch of times. And I'm going to enter again. Oh no, what happened? No, he didn't like that? Okay, sorry. Let's make that. I know why. My bad, guys. I hit hit the negative symbol, not the minus symbol. Yeah, always good when technology is 20 years old. Gets you. Yes, this technology is 20 years old. All right, so there's our area under the curve, 0.9235. So this right here is 0.9235. Okay, now here's where it gets really confusing. I know it's already been confusing. Make sure you're listening. I know, I'm not done yet. It's see the shaded area? That's the likelihood that someone is working less than 90 hours. Okay? So this right here, and maybe I should write that down for you, Adrian P. So this is the likelihood a volunteer worked less than 90 hours. Okay, so now here's the last part, and we're very close. Okay? Do you guys remember the 80th percentile over here, that 0.8?
Yes.
All right? If you take the area that we just found and subtract it from the 80%, you'll get the likelihood that someone who worked who worked less than 90 hours is still working above 80 to get the citation. Let me do it again. So you remember this part here? The area in the top 20%, they get the certificate of merit, right? So if I subtract, so I'm going to do 0.9235 minus 0.8, all right, that's going to give me, so 0.1235. This is not the answer. I know many people think it's the answer. This is the likelihood that you're going to get the merit, right, certificate of merit, and you worked less than 90. So now here's the last step. We're trying to find out that you worked less than 90 and you got the merit, given that you worked less than 90. That was that last part. Remember this part here? Given that the number of hours you worked is less than 90. So here's what you write down. You write down the 0.1235 number divided by my 0.9235 number. When you do that division, you will get the answer. It's 0.9235. Oh, that's and you got the certificate of merit, or the certificate of merit.
Without any explanation, how long do you think this would take you?
Me to do it, it would probably take me 2.5 minutes.
That is
For real? It's because you already know.
I believe you.
Yes, I do know how to do these.
It feels like you already know that problem.
Yeah.
It's a conditional probability wrapped up in the normal model, so it is tough.
So basically, skim over it.
Sure.
Wait.
So it's like 0.134, about 0.134. which is C.
So who made that?
Yes. I just divided 0.1235 divided by 0.9235. All right? All right. Thank you, everyone. I appreciate you. Don't forget to watch the next part.